the zeros or the solutions of a quadratic equation. And that's what this is. So I can't do anything with it as it is. I'm going to get this equation set equal to 0. So I subtracted 12 from both sides. Oh, now I have to come up with two binomials. Remember? And then I can figure out what x is. So we did the box and diamond, which you're more than welcome to use. But I think when this is 1 up here, it's really easy just to look at the last term, factors of negative 12 that add to negative 1. Factors of negative 12 that add to negative 1. I heard it. Negative 4 and positive 3. They multiply to negative 12 and they add to negative 1. And it's really just the box and diamond method, but we just can do it in our head when this is 1 here. So now I can write my factors. Those are my binomials. Then I set each one equal to 0 to see what x value would make that happen. So this is going to be x equals 4, and this is going to be x equals negative 3. Those are my solutions. That's where the parabola hits the x-axis, if you were to graph it, which we're heading into next chapter. Okay, so this is all going to play a part in what you're doing today. All right, radical equation. We looked at radical expressions already. An expression doesn't have an equal sign. A radical equation is an equation with a variable in the radicand. Do y'all remember what a radicand is? The stuff underneath? Like the discriminant. It's like the discriminant, yes. Extraneous. Say it. It's a fun word. Extraneous. An extraneous solution. Checking your solutions in the original equation, and if one doesn't work, it's extraneous. And we're going to look into that. All right. So we have to solve these. You need to undo the equation until you're left with just the radical before squaring. So let's see what I mean. So here's the radical. It's got 7 subtracted equals 0. I got to get rid of that minus 7 by adding 7. Just like I'm solving a regular equation. Same way. So now I have the square root of x equals 7. Anybody have any idea what to do now? Right on. What were you going to say, Chuck? Square it. Because you know that the square root and squaring are opposite. And they cancel each other out. So in order to get rid of that square root, I'm going to square both sides. These cancel each other out. I'm left with x equals 49. Okay, now we have to check. Make sure. So I'm going to stick the 49 in. Square root of 49 minus 7 equals 0. The square root was here. We did not insert it, so we don't have to consider the plus and the minus. We're just going to consider the positive. The square root of 49 is 7 minus 7, which is what?
0.
0, so it works. Okay. Let's do this one a little quicker. We're going to take apart this equation until we get the radical by itself. Add 6. Now what? Divide by 3. Now what?
The square thing.
The squaring, because I want just x. I'm going to square both sides. X equals 2.
What? X equals 4.
X equals 4. Just checking to see if you're awake. Tony is awake even. You got it, didn't you? Okay. So let's just check it in our head. Stick the 4 back in here. What's the square root of 4? 2 times 3, which is what? 6. Take away 6 is 0. We're good, yes? Okay. All right, I was going to have you do this one, but it gives you kind of a funky fraction, so I'm going to walk you through it. So add 3. Now what? Divide by 12. Okay, now I have the square root of x equals, whoa Nelly, can we reduce that fraction, make it easier? What would it be? 1/4. Let's do that. Okay, now it's the same thing. I don't want the square root, so what do? Square both sides. Okay, what is 1/4 times 1/4?
1/16.
Okay, fractions. You multiply straight across. It's 1/16. 1/16. And you say, oh, that's just nasty. Do we really have to plug it in? Yeah, it's not very hard. Let's do it. Let's try it. So I'm going to check by doing 12 times the square root of 1/16 minus 3 equals 0. It's not that bad because you already know what the square root of 1/16 is. What is it? 1/4. So 12 times 1/4 minus 3 equals 0. And you're like, oh, fractions, but they're not that bad. What's 12 times 1? 12 divided by 4. 3 minus 3. It's good. We're good. Solid. Okay? All right. This one is a little longer, but it's just more steps, just taking it apart. So I'm going to subtract 9, just like solving a regular equation. What else is still outside of the radical? The 2. So I got to get rid of the 2. Now, this is all under the radical. You cannot take it apart. You can't subtract 6. At this step, you just have to do what? Square both sides. Get rid of that radical.
Square the stuff inside the radical.
No, because it just cancels those out. No?
Oh.
Yeah. Okay? And then you subtract 6, and x equals 30. And if you stuck it back in here, it would work. It would be 2 times the square root of 36, which is 6, is 12, plus 9 is 21. All right, you try this one. You try that one. Same method. Try that one on your own. Turn it over. The second set of homework problems are going to be like these, which are just a little bit different, but really it's the same idea. Look, I can't really do anything here except get rid of the radicals. So what should I do right now to get rid of the radicals? Square both sides. Lost my red pen. Just square both sides. It's very pretty. Then you're left with x plus 4 equals 2x minus 1. Focus. Now you just have an equation with variable on both sides. You just have to go whatever method you want. I think it's easiest to just get rid of the x's here. It doesn't matter which way you go. You'll end up with the same answer if you do the math right. Add 1 to both sides. X equals 5. Now let's just check it to make sure. The square root of 5 plus 4 equals the square root of 2 times 5 minus 1. So this is the square root of 9. Does that equal the square root of 9? Yes, it does. So it works. Okay? All right, hey, look at this one. It's a little bit different looking than that one, isn't it? Yes, Mrs. Burgess, it's a little bit different.
Yes, Mrs.
Can we make this one look like this one? What can we do? Add the square root of the x to both sides, and then we'll have something that looks like, I'm going to write it like this. And then we'll have something that looks like this. Now we have 4x minus 3 equals the square root of x. I just drew a line there just to kind of show you what I did. Oh, now I can get rid of the radical by doing what? Squaring both sides. Parentheses or not, it doesn't matter. Now, all I'm left with is what's underneath the radicand. And then it becomes a pretty basic problem to solve for x. You can't subtract, you can, but you're going to take more steps. If you subtract x, you're going to get 0 here. So it makes more sense to do this. Negative 3 equals negative 3x. And divide by negative 3. And x equals 1. And it'll work when you stick it in there. All right, so this is the second type of problem you'll see. First set is this. Second set is these. And then the grand finale. Are you ready? All right, hey, let's look at that. That looks a little different. I can't subtract or divide anything, but I got to get rid of those square root things, so what should I do? I'm just going to square both sides. Look what happens when we do that. I'm going to square both sides. And then I end up with this. Oh, this looks just like that warm-up problem. It's a quadratic equation. In order to solve, I have to have it set equal to 0. I want you all to look up here right now, because if you miss this, it's going to be harder on yourself. If I subtract this and bring it over here, I'm going to have a negative x squared, and that's just a pain in the butt to factor. So I'm going to take these and move them over to this side and get it set equal to 0 that way. So I'm going to subtract 20 and add x over here. And watch, this is what I end up with. X squared plus x minus 20 equals 0. That's in the right order. That's ready to factor. Do y'all follow what I just did there? Just made it easier for myself. I moved these two over here to set equal to 0. So I don't have a negative x squared. That's yucky. Negative x squared is yucky. Yeah, well, you don't have to, but if you move this over here, you're going to have a negative x squared, and then you have to factor that into two binomials, and that's a pain. That's a pain. So now I've got to do my two binomials so I can find out what x is. Okay, in the beginning goes x and x, because that's got to be x squared. I'm going to look at negative 20, factors of negative 20 that add to 1. 5 and negative 4. So I'm going to add plus 5 and minus 4 here. Okay, if I set this equal to 0, I get x equals negative 5. If I set this equal to 0, I get x equals 4. Those are my solutions. Now I've got to make sure they're not extraneous. This is where the extraneous sometimes comes into play. So I'm going to plug them into my original equation, which is kind of messy. Square root of 20 minus the square root of 5. Does that equal negative 5? Minus, like, that's what it looks like when you stick x into your original equation. Stuck x in. Yes?
When we do the problems on like the homework and stuff, do you want us to like show you that we plugged everything back in?
No, but you probably will have to on the quiz. Okay, so this becomes the square root of 25. Now this is where you have to realize, oh, if I take the square root of 25, I could have a positive or a negative, couldn't I? Yes, so this actually works. Okay, then you stick in 4. Does that equal 4? Square root of 16 does equal 4, so that's all good. So those both work. All right, you try this one. You try this one. Same process we did here. Follow the steps. And we're almost done. Questions? Can you use the box and diamond? Absolutely, if you want to. Just takes a little longer. Yes.
How's the square root of 1?
Remember, when you take the square root of a number, you can have a positive and a negative version. Yeah, it's all right. I know it's kind of tricky because you toggle back and forth using that and not using it. I know. All right, this is a pretty quick story problem. It says if friction is ignored, the velocity of a roller coaster when it reaches the bottom of a hill can be found using this formula. V equals the square root of 64 times h, where h is the height in feet of the hill. H is how high the hill is. The approximate velocity of one of the fastest roller coasters in the world is 176 feet per second. Per second. Can you imagine that? They're saying that that's velocity. You got to find the height. I got to find h. So all you do is you plug this in for v. And how do I solve that? Yes?
You would take the square root of 64, which is 8, and then divide 8 on both sides. And once
Yes.
you did that, you would have 22 equals h squared equals square root of h, and then you would square both sides, and you would get 484 equals h.
She's absolutely correct. You can do that. Or you can go ahead and square it right here too. Either way.
That's cool.
You can get it either way. Perfect. That was good thinking. I didn't even think about that. So if you square it right now, you can do it the way Katie said, or you can square it right now and you're doing the same process.
But that's a lot harder.
It's fine. It's good thinking. Divide by 64. And you got the same answer, correct? 484 feet.